Welcome back, guys, to lecture number 8. Today we will talk about the project quality management. The content of the lecture is definition, overview of the project quality management process, project quality and management, quality, grading, precision, accuracy targets, modern quality management approaches, plan quality management, perform quality assurance, control quality, and at the end of the lecture I will explain about how to work with mentor and how you can find your mentors. And also at the end of the lecture you will have task number 4. So definition: project quality management includes the process and activities of the performing organization that determine quality policies, objectives and responsibilities so that the project will satisfy the needs for which it was undertaken. Project quality management uses policies and procedures to implement within the project's context and organization's quality management systems, and as appropriate, it supports continuous process improvement activities as undertaken on behalf of the performing organization. Project quality management works to ensure that the project requirements, including product requirements, are met and validated. Plan quality management: the process of identifying quality requirements and standards for the project and its deliverables, and documenting how the project will demonstrate compliance with quality requirements. Perform quality assurance: the process of auditing the quality requirements and the results from quality control measurements to ensure that appropriate quality standards and operational definitions are used. Control quality: the process of monitoring and recording results of executing the quality activities to assess performance and recommend necessary changes. Project quality management addresses the management of the project and deliverables of the project. It applies to all projects, regardless of the nature of their deliverables. Quality measures and techniques are specific to the type of deliverables being produced by the project. In either case, a failure to meet the quality requirements can have serious negative consequences for any or all of the project's stakeholders. For example, meeting customer requirements by overworking the project team may result in decreased profits and increased project risks, employee attrition, errors, or rework. Meeting project schedule objectives by rushing planned quality inspections may result in undetected errors, decreased profits, and increased post-implementation risks. Quality and grading. Quality and grade are not the same concepts. Quality as a deliverable performance or results is the degree to which a set of inherent characteristics fulfill requirements. Grade is a design. Intent is a category assigned to deliverables having the same functional use but different technical characteristics. The project manager and project management team are responsible for managing the trade-off associated with delivering the required levels of both quality and grade. While a quality level that fails to meet quality requirements is always a problem, a low grade of quality may not be a problem. For example, it may not be a problem if suitable low-grade software product, one with a limited number of features, is of high quality, no obvious defects, readable manual. In this In this example, the product would be appropriate for its general purpose of use. It may be a problem if a high-grade software product, one with numerous features, is of low quality, many defects, poor organized user documentation. In a sense, it is high-grade feature set would prove ineffective and or inefficient due to its low quality. Precision. The project management team should determine the appropriate level of accuracy and precision for use the quality management plan. Precision is a measure of exactness. For example, the magnitude for each increment on the measurement's number line is the interval that determines the measurement's precision. The greater the number of increments, the greater the precision. The basic approach to project quality management is, as described in this section, is intended to be compatible with the International Organization for Standardization quality standards. Every project should have a quality management plan. Project teams should follow the quality management plan and should have data to demonstrate compliance with the plan. Accuracy and targets. Accuracy is the assessment of correctness. For example, if the measured value of an item is very close to the true value of the characteristic being measured, the measurement is more accurate. All illustration of this concept is the comparison of arbitrary targets, arrows clustered tightly in one area of the target, even if they are not clustered in the bull's eye, are considered to have high precision. Targets where the arrows are more spread out but equidistant from the bull's eye are considered to have the same degree of accuracy. Modern quality management approaches. Customer satisfaction. Understanding, evaluating, defining, and managing requirements so that customer expectations are met. These requirements are a combination of conformance to requirements to ensure the project produces what it was created to produce, and fitness for use the product or service needs to satisfy the real needs. Prevention over inspection. Quality should be planned, designed, and built into, not inspected into the project's management or the project's deliverables. The cost of preventing mistakes is generally much less than the cost of correcting mistakes when they are found by inspection or during usage. Continuous improvement. The plan, do, check, act cycle is the basis for quality improvement as defined by Shewhart and modified by Deming. In addition, quality improvement initiatives such as the Total Quality Management, Six Sigma, and Lean Six Sigma could improve the quality of the project's management, as well as the quality of the project's product. Commonly used process improvement models include Malcolm Baldrige Organizational Project Management Maturely Model and Capability Maturely Model Integrated. Management responsibility. Success requires the participation of all members of the project team. Nevertheless, management retains within its responsibility for quality a related responsibility to provide suitable resources at adequate capacities. Cost of the quality. Cost of the quality refers to the total cost of the conformance work and the non-conformance work that should be done as a compensatory effort because on the first attempt to perform that work, the potential exists that some portion of the required work effort may be done or has been done incorrectly. Here's a project quality management overview. Here, plan quality management, perform quality assurance, and control quality. Here's a diagram of the working. And plan quality management. Plan quality management is the process of identifying quality requirements and or standards for the project and its deliverables and documenting how the project will be demonstrating compliance with relevant quality requirements. Here in the input project plan, project management plan, stakeholders register, risk register, requirements documentation, enterprise environmental factors, organizational process assets. In tool and techniques, cost benefit analysis, cost of quality, 7 basic quality tools, benchmarking, design of experiments, statistical sampling, additional quality planning tools, meetings. In outputs, quality management plan, process environment plan, quality metrics, quality checklists, project documents, updates. So workflow, cost benefit analysis. The primary benefit of meeting quality requirements includes lesser work, higher productivity, lower cost, increases stakeholder satisfaction, and increases profitability. A cost-benefit analysis for each quality activity compares the cost of the quality step to the expected benefit. Benchmarking. Benchmarking involves comparing actual and or planned project practices to those of comparable project to identify best practice, generate ideas for improvement, and provide the basis for measuring performance. Benchmarking projects may exist within the performing organization or outside of it. It can be within the same application area. Benchmarking allows the analysis from projects in a different application area to be made. Cost of quality. Cost of quality includes all costs incurred over the life of the product by investment in preventing non-conformance to requirements, appraising the product or service for conformance to requirements, and failing to meet our requirements. And 7 basic quality tools. The 7 basic quality tools, also known in the industry as 7 QS tools, are used within the context of the PDCA cycle to solve quality-related problems. Cause and effect diagrams, which are also known as fishbone diagrams or as Ishikawa diagrams. The problem statement placed at the head of the fishbone is used as a starting point to trace the problem source back to its actionable root cause. In Russian, we have a proverb like "Ryba гниет с головы." Yeah, it's about this diagram. The problem statement typically describes the problem as a gap to be closed or as an objective to be achieved. The causes are found by looking at the problem statement and asking why until the actionable root cause has been identified or until the responsible possibilities on each fishbone have been exhausted. Fishbone diagrams often prove useful in linking the undesirable effects seen as a special variation to the assignable cause upon which project teams should implement corrective actions to eliminate the special variation detected in a control chart. Check sheets, which are also known as tally sheets and may be used as a checklist when gathering data. Check sheets are used to organize facts in a manner that will facilitate the effective collection of useful data about the potential quality problem. They are especially useful for gathering attributes data while performing inspections to identify defects. For example, data about the frequencies or consequences of defect collected in check sheets are often displayed using Pareto diagrams. Flowcharts, flowcharts, which are also referred to as the process maps because they display the sequence of steps and the branching possibilities that exist for a process that transforms one or more inputs into one or more outputs. Pareto diagrams exist as a special form of vertical bar chart and used to identify the vital few sources that are responsible for causing most of a problem's effects. Histograms are a special form of a bar chart and are used to describe the central tendency, dispersion, and shape of a statistical distribution. Control charts are used to determine whether or not a process is stable or has a predictable performance. Scatter diagrams plot ordered pairs X and Y and are sometimes called correlation chart because they seek to explain a change in a dependent variable Y in a relationship to a change observed in the corresponding independent variable X. Design of experiments. Design of experiments is a statistical method for identifying which factors may influence specific variables of a product or process under developing or in production. Statistical sampling. Statistical sampling involves choosing a part of a population of interest for inspection. For example, selecting 10 engineering drawings at random from a list of 75. Additional quality planning tools. Other quality planning tools are used to define the quality requirements and to plan effective quality management activities. These include, but are not limited to, brainstorming, force field analysis, nominal group technique, quality management and control tools. The quality management plan is a component of the project management plan that describes how the organization's quality policies will be implemented. It describes how the project management team plans to meet the quality requirements set for the project. The quality management plan may be formal or informal, detailed or broadly framed. The style and detail of the quality management plan are determined by requirements of the project. The quality management plan should be reviewed early in the project to ensure that decisions are based on accurate information. The benefit of this review can include the sharper focus on the project's value proposition and reductions in costs and in the frequency of schedule overruns that were caused by rework. Process improvement plan. Process improvement plan is a subsidiary or component of the project management plan. The process improvement plan details the steps for analyzing project management and product development process to identify activities that enhance their value. Areas to consider include process boundaries, process configuration, process metrics, targets for improvement performance. Quality metric. A quality metric specially describes a project or product attribute and how the control quality process will measure it. Quality checklist. A checklist is a structured tool, usually component specific, used to verify that a set of required steps has been performed. Quality metric. Quality metrics specially describes a project or product attribute and how the control quality process will measure it. A checklist is a structured tool, usually component specific, used to verify that a set of required steps has been performed. Perform quality assurance. Perform quality assurance is the process of auditing the quality requirements and the result from quality control measurements to ensure that appropriate quality standard and operational definitions are used. The key benefit of this process is that it facilitates the improvement of quality process. The quality assurance process implements a set of planned and systematic acts and process defined within the project's quality management plan. Here in input quality management plan, process improvement plan, quality metrics, quality control measurements, quality documentation. In tools, technique, quality management and control tools, quality audits, process analysis. In output, change request, project management plan updates, project documentation updates, organizational project assets updates. Here's the workflow of perform quality assurance. Quality assurance contributes to the set of being certain about the quality by preventing defects through the planning process or by inspecting out defects during the work in progress stage of implementation. Perform quality assurance is an execution process that uses data created during plan quality management and control quality process. In the project management, the prevention and the inspection aspects of quality assurance should have a demonstrable influence on the project. Quality assurance work will fall under the conformance work category in the cost of quality framework. Quality management and control tools. The perform quality assurance process uses the tool and techniques of the plant quality management and control quality processes. In addition, other tools are available include affinity diagram, process decision program charts, PDPC, interrelationship graph, an adaptation of relationship diagrams. The interrelationship graph provides a process for creative problem solving in moderately complex scenarios that possess intertwined logical relationship for up to 50 relevant items. 3 diagrams, also known as a systematic diagram, and may be used to represent the composition hierarchies such as the WBC, RBC, risk breakdown structure, and OBC, organizational breakdown structure. Prioritization matrices. Identify the key issues and the suitable alternatives to be prioritized as a set of decisions for implementation. Activity network diagrams, previously known as the arrow diagrams. They include both the activity on a row and the most commonly used activity on node. Formats of the network diagram. Matrix diagram, the quality management and control tools used to perform data analysis with the organizational structure created in the matrix. Storyboard illustrating the 7 quality management and control tools. Quality audits. Quality audits is a structured independent process to determine if project activities comply with the organizational and the project policies, processes, and procedures. The objectives of the quality audits may include identify all good and best practice being implemented, identify all non-conformity gaps and shortcomings, share good practice introduced or implemented in similar projects in the organizational and or industry, proactively offer assistance in a positive manner to improve the implementation of a process to help the team rise productivity. Highlight contributions of each audit in the lessons learned repository of the organization. The subsequent effort to correct any deficiencies should result in the reduced cost of quality and an increase in sponsor or customer acceptance of the project's product. Quality audits can confirm the implementation of approved change requests, including updates, corrective actions, defect repairs, and preventive actions. Process analysis. Process analysis follows the steps outlined in the process improvement plan to identify needed improvements. This analysis also examines problem experienced, constraints experienced, and non-value added activities identified during the process operation. Process analysis includes root cause analysis, a specific technique used to identify a problem, discover the underlying causes that lead to it, and develop preventive actions. Control quality. Control quality is the process of monitoring and recording results of executing the quality activities to assess performance and recommend necessary changes. The key benefit of this process include identifying the causes of poor process or product quality and recommending and or taking action to eliminate them. Validating that project deliverables and the work meet the requirements specified by key stakeholders necessary for final acceptance. Here in input you have project management plan, quality metrics, quality checklist, work performance data, approved change, request, deliverables, project documents, organizational process sets. 7 basic quality tools: statistical sampling, inspection, in tools and techniques, approved change request review. In output, quality control measurement, validated changes, verify deliverables, work performance information change requests, project management plan updates, project documentation updates, and organizational process assets updates. It's a workflow of control quality. The control quality process uses a set of operational techniques and tasks to verify that the delivered output will meet the requirements. Quality assurance should be used during the project's planning and executing phases to provide confidence that the stakeholders' requirements will be met, and quality control should be used during the project executing and closing phases to formally demonstrate with the reliable data that the sponsor and or customer's acceptance criteria have been met. The project management team may have working knowledge of statistical control process to evaluate data contained in the control quality output. Among other subjects, the team may find it useful to know the difference between the following pairs of terms: prevention, attribute sampling, and tolerances. Inspection. An inspection is the examination of a work product to determine if it conforms to documented standards. The results of an inspection generally include measurement and may be conducted at any level. For example, the results of a single activity can be inspected, or the final product of the project can be inspected. Inspections may be called reviews, peer reviews, audits, or walkthroughs. In some application areas, these terms have narrow and specific meanings. Inspections are also are used to validate defect repairs. Approved change request review. All approved change requests should be reviewed to verify that they were implemented as approved. Quality control measurements. Quality control measurements are the documented results of a control quality activities. They should be captured in the format that was specified through the plant quality management process. Validated changes. Any changed or repaired items are inspected and will be either accepted or rejected before notification of the decision is provided. Rejected items may require rework. Verified deliverables. The goal of the control process is to determine the correctness of deliverables. The result of performing the control quality process are verified deliverables. Verified deliverables are an input to validate scope for formalized acceptance. Work performance information. Work performance information is the performance data collected from various controlling processes, analyzed in the context and integrated based on a relationship across areas. Examples include information about the project requirements fulfillment, such as the causes for rejections, rework required, or the need for process adjustment. Okay, it's the end of the lecture. So starting from this week, you will work with your mentor. Who is the mentor? A mentor is a person who works in industry, who is the staff of some company or staff of some organization. And your first task is to find a team mentor till 31st March. I have some kind of list of mentor. If I'm not mistaken, I have 25 mentor who gave their who was agreed to work with you, and I will share this list in Telegram channel. You can text with them to them and explain your position, maybe explain your projects. If they are interested, they can accept you as their team. And also, one team, one mentor. Every mentor can have only one team. After how you will find your mentor, you must sign agreement between you and between mentor. I will share this agreement on the Telegram channel, and after signing you have to upload, not you, project manager of the team has to upload the signed agreement by this link. Okay, so in the list I have only 25 mentor. You can text to them, or you can find your own mentor. But here process will be like this. You will find your own mentor and give me the contacts of your mentor. I will contact to them. I will have some kind of conversation with them, and after that I will give permission to work with this mentor. Also, your mentor must not be your relatives, your brother, your group mates, your friends. They are not allowed. I think also task. I think with mentor it's clear. If you have questions, you can text me on Telegram. And also task number 4. Make videos with your mentor and upload to team YouTube channel. After how you will find your mentor, you have to upload the video. Your video must contain what are you planning to do in general or in personal. Like your mentor is speaking like, I'm planning to do some kind of project with this team, and you are explaining. You can explain in general, like you can explain your general idea of your project. Also, maybe you will have some kind of done process. Maybe you will, for example, you will draw the design of your web page, and it's a first stage on the process, on the making project. So like you have already done with the design, and you are like explaining it till 9th April. And approval from your mentors in two both videos. Like on the first video there must be your mentor, and also on the second video there must be your mentor. Also, at the end of the semester your mentor will put some kind of percent from your mark, from your total mark. My advice, try to work with your mentor honestly, because it's very important. Maybe you will have earned a great experience from your mentors, and it's very important part. Okay, thank you. I think that's all for